Today, biotechnology is a very familiar part of everyday life. Products produced with recombinant DNA technology are all around us. They're in the food we eat, in the fuels we use, they even clean up the fuels we spill. And of course, they were first used to develop the medicines we need to lead healthy lives. It's easy to think the technology has been around forever, but that's not the case. It all began with the expression of the human protein in bacteria on August 15, 1977. No one thought it could be done at that time. So how did it happen? What was it like for a group of 20-some-year-old scientists and a 28-year-old entrepreneur to create an industry? I had the pleasure of speaking with two very important pioneers in the creation of the biotech industry. Roberto Crea, who was on the team at the City of Hope that expressed the first protein, and Tom Kiley, who was one of the fathers of genetic patent law.
My name is Roberto Crea, and I was one of the really early scientists who joined Genentech in 1977. I was recruited by Bob Swanson and Keiichi Takura to come to join the team at a very early stage in 1976. And at that time I was working in the Netherlands in the laboratory of Professor Van Boom, and I was doing some specialty chemistries. Specifically, I was one of the few experts in DNA synthesis. So Bob Swanson wrote me a letter at the end of 1976 asking whether I would like to spend a couple of years in California. Of course, for me as a young postgraduate PhD in Europe, California, of course, was very appealing. So I joined the team at the time when they were starting. They had started working on the synthesis of the first synthetic gene, the somatostatin. And of course, the reason why I was recruited was very simple. They had some problems. The synthesis was very difficult at that time, so they needed experts, and they recognized me, one of the worldwide experts. So I joined, and I was very lucky because very early on, almost after 2 weeks, I made a very important discovery, and that really facilitated and streamlined the synthetic DNA. Obviously, that was very important because we had to put together 8 fragments of synthetic DNA to make a first gene called somatostatin, and I was able to combine chemistry improvements and also an easy way to purify these fragments. Otherwise, you get a really big mess if you don't clean the end product. So we were very, very successful in that, and only after a few months that I joined the team at City of Hope, we made a big announcement that we had accomplished the first synthetic gene for a mammalian protein, and that gene had been cloned by a molecular biologist at Genentech, and we had a very successful experiment in producing the active mammalian protein, which was the first time. So at that time, I took over basically the laboratory operations, and I started designing the genes, and then planning for a synthesis of a very large number of pieces of DNA, which everybody thought was an impossible task to accomplish in less than 5 years. So we were able to complete the insulin synthesis of both the A chain and B chain in less than 5 months, actually. And that was really a major contribution that we gave to the growth of Genentech. So the big difference from academia, and especially in Europe, I was in Leiden University in the Netherlands, and California was really the motivation. In academia, you often work on research, but really your ambition is to write a nice paper to let your colleagues know what the quality of your research, and eventually get a lot of recognition, as a scientist, as professional. In a small company like Genentech was more, hey, we have to produce, we have to get something that we can put in the market because the company needs to sell a product and the patient need to get the benefit out of this technology. So really we tackle major challenges as a team. And that was a great feeling because often if you work in the academia, you work in a more isolated fashion. You have your people and so on. But here it was like, oh, let's go together. And now we're going to win together. We're going to lose together. So I think the synergy, it was very important. The friendly atmosphere.
The science was clearly the nucleus for the biotechnology revolution, but it could not have become an industry without the ability to patent discoveries. This is where Tom Kiley truly excelled.
Bob came into my office in Los Angeles and said, I'm going to make a major independent pharmaceutical company around something called recombinant DNA. And I said to myself, sure you are, kid. But outwardly I embraced the opportunity to charge him for my time. It fell to me to file the company's first patent applications around the somatostatin, and within a year the insulin work. And after that, next came human growth hormone, and then the various interferons. By 1980, the company had, with some assistance from me and a lot of work on Bob's part and others, built partnerships with 3 major companies in the pharmaceutical business, had expressed growth hormone, insulin, somatostatin, and possibly the first of the interferons, and was primed to go public. One of the impediments to going public was the controversy over the question whether patents would be available for genetically engineered microorganisms. And the patent office had said no. And I said to Bob, assume there will be no patents and run like hell to be first to market and build a strong scientific team and see if you can't win in other ways. And if the patents do come, they'll be the icing on the cake. I also asked Bob to let me file a so-called friend of the court brief, or amicus brief, at what was then called the Court of Customs and Patent Appeals, on the question whether we could patent these microorganisms. And being Bob, he said, well, okay, as long as it doesn't cost me any money. And so I did it and charged him only what it cost to print the brief. And we prevailed there, but the government took the case up to the United States Supreme Court. And one of my last acts before leaving my law firm and joining the company was to write the amicus brief in the Supreme Court on that question. There was a great fuss being made over the issue whether Congress had specifically excluded patents on living organisms when it created something called the Plant Variety Protection Act and the Plant Patent Act and so on. And there was a lot of complexity about the legislative history, but in the end, the argument that won the day, cut through the Gordian knot, if you will, was simply this, and it was the argument that Genentech made. We said to the court, this is way too complicated for the court to pass upon. The petitioners are asking the court to take a meat axe to the patent laws, which by their very nature seek the discovery of things not within the ken or the vision of patent law making politicians. It's a great charter for innovation, and only the Congress can balance the competing social and other economic aspects of deleting something from the broad campus of the patent court or the patent laws. And the court saw that and said, we don't have to decide this. If Congress wants to shrink the Patent Act, let them do it. And there was a 5-4 decision in our favor that came just 4 months before the public offering. And I can't help but think that the offering might have been a little more difficult if the court had gone the other way.